Hey everyone, thank you for joining my session on Cloud Native Database on Kubernetes. This session is for folks interested in learning leading trends of database innovations, cloud native architecture, self-driving, autonomous operations, and cost optimizations, and many more things. Before I get started, a quick intro about me. I am Anil Kumar, Director of Product Management at Couchbase. I'm responsible for product strategy, vision, and go-to-market for our flagship products, Couchbase Server, Cloud Native Database on Kubernetes. And here are some of my accomplishments in the last 9 years of my time in Couchbase. So with that, let me get started. So we've been talking about cloud computing and cloud migration for a long time, but a look at the application portfolios of many organizations confirms that there are still a lot of work to be done. In many cases, challenges with database not being part of modern architecture, meeting the multi-cloud or hybrid cloud strategy, and the ability to be part of continuous delivery pipelines continues to be the key limiting factor in cloud adoption. And this is why it is important to understand how cloud native architecture can help solve those challenges. So what is cloud native architecture? So the cloud native architecture is a design methodology for building both stateless and stateful applications and running them on a containerized and a dynamic orchestrated platforms that fully exploit the advantages of the cloud computing model. The cloud native architecture is about how applications are created and deployed, not worrying about where they're going to be deployed and how they are going to be configured. Such architectures empowers the organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. These applications are built ground up, designed as loosely coupled systems. They are optimized for cloud scale and performance, use automated operations, and take advantage of continuous delivery to achieve the reliability and faster time to market. So the overall objective is to improve the speed, scalability, elasticity, and finally the cost margin. So now the big question is, why do the database needs to adopt cloud native architecture? So here are some of the insights I've gathered from the past few years talking to hundreds of our customers, top analysts, developers, and DevOps engineers. The one word keeps repeating every time is standardization. So you don't want your database to get siloed into a separate infrastructure, a separate platform, or a separate lifecycle management, because that will create a huge hurdle for your goals of speed, elasticity, and cost. Right? Deploying and running your stateless and stateful application on a single target architecture will remove that impedance mismatch and simplify the whole developer and DevOps experience. From a business perspective, it gives you a freedom and the power to pick any cloud infrastructure, multi-cloud, hybrid cloud, or in some cases, even the on-prem deployments. Apply the security guardrails, not just for the stateless, but also for the stateful application on the single target architecture. Lastly, to achieve the elasticity and cost optimization with the cloud computing platforms. So let's take a look at, now that we understand the importance of adopting a cloud native architecture for applications, let's find out why a cloud native application, in our case a database, must run on containers and Kubernetes. To answer this question, I have to take you back in time. So in 2016, we all saw a hockey stick hype cycle with the adoption of container technologies. Although it was a great architecture for stateless applications since there is no state to be maintained, there was a significant concern, or I would say skepticism, about running the stateful workloads such as database or logs, on the containers. Many well-known authors and the industry leaders published articles at that time talking about why not to run a database on containers? Is containers good for your database? And you'll see many of those titles on the articles, such as, is Docker good for your database? And should you run your database on Docker? Well, the rest of the industry was skeptical about it. Couchbase, on the other hand, took a thought leadership by undertaking a considerable work or considerable task of production certifying Couchbase a NoSQL distributed database on container platform. In 2017, we started seeing slightly different mindset of articles. Here, the developers who fall in love with Docker and were already using Docker for their applications wanted to use the containers for even running the database in development and test environments. And in very small cases, they were also considering running the database on containers in production for small use cases. And again, this is where you'll see that there was slight change in the mindset, but still it was the maturity and skepticism about why not to run your database on containers. Coming to 2018, now we started seeing a huge spike in the interest from many IT organizations wanting to run the database in production using the container orchestration technology. You will see many articles, Docker, Kubernetes, and rise of cloud-native databases, evaluations of container orchestration systems for deploying and managing NoSQL database clusters. Although there were still many who did not believe database were meant to be run on the container orchestration, containers and Kubernetes. For example, Kelsey Hightower, who a well-known Googler on a DevOps world, tweeted in 2018, and in his last sentence of the tweet, it says, "Prefer not to run database on Kubernetes." Obviously, things have changed a lot, but this was back in 2018. Like earlier, Couchbase, on the other hand, released the Couchbase Autonomous Operator, a 1.0, which was our native integration of Couchbase on Kubernetes using the operator framework. And I'll talk about that in the next few slides. So building a Couchbase operator for Kubernetes was a game changer. And this is not just for Couchbase. Building an operator for any applications, it could be a stateless application or stateful application, is in fact a game changer. Right? And I'll talk about the Couchbase Autonomous Operator in more details in the next few slides. Fast forward 2021, the containerization of database is going mainstream. You see articles now calling out why Kubernetes is the best technology for running cloud-native database. Pivotal role of automated database in Kubernetes. What makes a database a good fit to run in Kubernetes? And there are many of those articles, and they point out how the database marries very well with the Kubernetes. And so this new term of cloud-native database comes into the picture. Now let's take a look at the Couchbase's journey in building a cloud-native database stack. So I talked about last few years and what has changed in the perception of running the database on containers. So our journey, in fact, started very long ago, right? Although I have put 2015 here on my journey, even before 2015, we had attempted, when Docker itself was in an infant state, Couchbase attempted to run Couchbase instances on the Docker containers. In 2015 is when we officially launched Couchbase on Docker Hub. And today, if you visit Docker Hub, you'll see the Couchbase is one of the top 10 repository on the Docker Hub, with the 50 million plus downloads on the Docker. In 2016, we were the first NoSQL database to fully containerize and productionize Couchbase, a NoSQL distributed database on containers. In 2017, we partnered with one of their tier 1 customer, Amadeus, and partner Red Hat in building a proof of concept of running Couchbase on OpenShift. OpenShift is an enterprise Kubernetes platform. That was hugely successful. We in fact did a presentation at the Red Hat Summit in Boston in 2017, and this was one of the best sessions, best rated sessions. And from there, in 2018, we went ahead and built a product called Couchbase Autonomous Operator 1.0. And this was released in August of 2018. Again, we were the first NoSQL database to build a native integration with Kubernetes. From there, since then, we have multiple minor releases and a major release last year, 2.0. And I'll talk about all the innovation and capabilities we have built on this product. The result of the last 4 years of effort and constant innovation is the full-fledged cloud-native database stack. The cloud-native database is a culmination of Couchbase Server, our core product, and the native integration with the cloud-native open source projects such as Kubernetes, Prometheus, Helm, CNI, Core DNS, Operator Framework, Ceph, GlusterFS, STO Service Mesh, Open Source Broker API, and Fluentbit. These are all in their own ecosystem. They are all the de facto standards. For example, Kubernetes is a de facto standard in the container orchestration. Prometheus has become a de facto standard for monitoring. FluentD and FluentBit have become a de facto standard for logging, log forwarding, and log analysis. And so we have picked all of those cloud-native technologies which are de facto standard and built the integration with Couchbase. And that is what we call the cloud-native database stack. The autonomous operator, which is the operator for the native integration with Kubernetes, is our core component of the cloud-native database stack. And it has integrated with the various other cloud-native technologies. The autonomous operator is the prerequisite to be able to use this cloud-native integration or cloud-native database stack. So let me talk about what this Couchbase Autonomous Operator is. So if you're familiar with Kubernetes architecture, the Kubernetes has master and it has worker nodes. And so there is one of the important component of the master is the controller. And that controller manages the lifecycle of the pods which is getting created on the worker nodes. So what the Kubernetes provides with this operator framework is for applications to build our own custom application-specific controller, where we can embed our own best practices. We can put our own knowledge about how to run, configure, and deploy Couchbase cluster, right? And that's exactly precisely what we have done with the Couchbase Autonomous Operator. We have embedded our best practices guidelines. We have automated all our database operations with the Couchbase Autonomous Operator. So let me go into so here are the list of capabilities, and I have put those in 4 boxes: deployment and configuration, lifecycle management, security, and high availability. And so in each of those areas, you will see there are many product capabilities we have shipped, starting from 1.0 and more advanced level capabilities such as automated upgrade, auto scaling capability using thresholds, and the cluster hibernation. And many of those capabilities are built into the product over the last 3 years. So let's take a look at the main benefits with running the Couchbase on the containers and Kubernetes, and mainly using this cloud-native database stack. So as I mentioned, the cloud-native database stack provides you. It's not a simple. So in the past, when we think about when you want to deploy Couchbase server, a Couchbase cluster on containers, you'd have to deploy the Couchbase, write your own scripts to deploy Couchbase on containers, and then you have to manage the lifecycle. And so we solved that by providing the Couchbase Autonomous Operator. So that solved one part of the equation, which is like now you can deploy a Couchbase cluster on Kubernetes using the Autonomous Operator. But there are other areas where, like, how do you monitor? How do you do full stack monitoring of your deployment, entire deployment? You can have one Couchbase cluster, you can have hundreds of Couchbase cluster deployed. How are you going to configure the cross data center replication between the Couchbase clusters? And so there are many other challenges. And this is where we started building those other integrations and on the networking side, on storage, on the monitoring and the logging and stuff. So for the monitoring, as I mentioned, we picked the de facto standard, which is Prometheus. And so we built a native, we built our own a native integration of Prometheus, and we have built a exporter which we provide to the users so that they can start exporting the stats from Couchbase cluster. And we also provide a out-of-the-box default dashboards which can be used for monitoring the multiple Couchbase clusters. Right? And so there are also sample alerts we can configure so that you can get alerts from the Couchbase clusters. So this was on the monitoring side. In our last release, we also launched integration with FluentBit. FluentBit is a lighter version of FluentD, which is more performant and optimized. And so what it provides is it forwards logs from Couchbase cluster to any system, any other system you want, right? So it basically structures them and then forwards them out of the Couchbase cluster. So this is more on the logging and log analysis. Similarly, on the persistent storage, we certify running Couchbase with the different persistent volumes. We support Ceph, GlusterFS, Portworx. On the managed Kubernetes services such as Amazon AKS, Azure AKS, Google GKE, we support their default storage classes. Right? And on the networking side, we have certified STO, and we also have we test the cross data center application, setting up the XDCR between cross data center application between Couchbase clusters deployed within the same Kubernetes cluster or different Kubernetes clusters. And all of that is documented in our documentation. So one last thing is with every release of Couchbase cluster, we fully certify the Couchbase components, like all the components I mentioned, and also the managed Kubernetes services, such as EKS, AKS, and GKE, and also our partner Red Hat OpenShift. And we have been adding more platforms. In the last release, we added Rancher as another Kubernetes platform we certify. So as I said, there are a lot of benefits with standardizing by standardizing into a single architecture for both stateless and stateful applications to increases the speed of delivery, and by including database in the same continuous delivery pipelines. It solves the multi-cloud or hybrid cloud strategy, being able to deploy on any infrastructure. It gives you freedom and power to be able to deploy and run on any of those cloud infrastructure. And then on top of that, most of the database operations are fully automated. So it reduces your operational cost by 90 to 95%. And our goal is being able to automate all the database operations. So starting from the provisioning, configuration, lifecycle management, even the upgrade, all of that fully managed, fully automated. With that, actually, here are some resources, links to the product page, blogs, and documentation. And so feel free to visit those sites. With that, thank you very much. Thanks for attending my session.